And so, guys, welcome to the part 8 of our lecture, Becoming a LEED Green Associate, preparing you for the LEED Green Associate exams. In this part, we're going to be talking about energy and atmosphere. Let's go. For the content highlight of this part, energy demand, energy efficiency, refrigerant management, renewable energy, and also ongoing performance. And so what is energy? Energy is defined as the capacity to work, and it comes in different forms: heat, light, electricity, and other. And this is often sourced from fossil fuels. And like we said before, this contributes heavily to the greenhouse gas emissions. In the United States alone, buildings consume about 39% of the annual energy and 74% of electricity. And that's what led to the calls for sustainable approach to power generation and indeed other activities in the construction industry. Okay, so to counteract these issues, sustainable design and construction has been advocated by LEED addresses energy comprehensively, and that's what we're going to be studying in this chapter of our lecture. So this category has a number of strategies by which the sustainable measures are driven in order to get the triple bottom line benefits, and they are: one, by controlling energy demand; number two is by improving energy efficiency; number three is the management of refrigerants; and promotion of the use of renewable energy was number four; and also the performance of energy during the building use, operations and maintenance, which is ongoing performance. The benefits environmentally is that the fossil fuel reliance will be reduced, and this will combat air pollution. And this the focus is on promoting eco-friendly renewable energy sources. There are also eco benefits, because this will lower costs related to fuel purchases, and to reduce expenses on energy providers. Socially, of course, like I said, productivity and well-being is improved once air pollution is controlled. Now let's talk about energy demand. The entirety of the energy system is driven by demand, as all of the installations and provision of infrastructure is geared towards meeting demand. So this is what influences total energy consumption, types of fuel, technologies deployed, and also geographical distribution. The strategies to mitigate demand involves reducing the load required for lighting, for space cooling, and for heating. So when we engage sustainable methods such as improving daylight, maximizing wind or geothermal alternative, and of course renewable sources like solar, we are able to effectively reduce energy demand which serves as a good platform for promoting energy efficiency in our projects. Now, what are these strategies? One, reducing peak energy demand. This is crucial for enhancing network efficiency, especially when this is done to curtail energy use during peak periods. We promote network efficiency and minimize the need for endless expansion. This reduction strategies also contribute to avoiding the investment in excess capacity and infrastructure. Subsequently, reducing greenhouse gas emissions. And then, when we integrate energy storage system alongside renewable sources, we're able to balance power supply with demand during peak times, which helps the power networks to be more efficient and more reliable. So that is the first strategy of reducing energy demand at peak periods. Now we also talk about project location. It is needless to say that the location of the project would impact its energy requirements. For example, in a new location without existing infrastructure, the provider must expand capacity to meet the project's energy needs. And consideration of energy characteristics in the energy and atmosphere credit category is vital, working in alignment with the location and transportation credit category, because the project selection, project location would influence the energy requirement. So I think personally this is key or primary consideration. If we get the location of our project right, we'll possibly fare better in the area of demand for infrastructure. Number 3, the building design itself. After the project location, emphasis should also be given to ensuring that there are efficient design strategies, right, that reduce energy demand within the building. This should account for climate conditions, such as outdoor temperature, the solar radiation, humidity, and wind. So it's important that even when the location is getting right, the design must not act in isolation of the environmental conditions. It must take into cognizance the prevailing environmental factors and environmental opportunities to come up with a responsive and efficient design. Addressing heat losses or gains is essential. For example, in colder climates, maximizing solar gains can reduce the need for excessive heating, while in an hotter climate, it is the opposite. And then Natural ventilation also, an active use of renewable source, solar energy, should be considered in the design, taking advantage of proper orientation, sizing of fenestrations, and of course the composition of the unit, facilitating easier energy demand reduction. This is important. The designer must ensure that the energy goals of the owner of the client is properly considered and must be expressed in the choice of materials and choice of strategies incorporated in the design. So next we'll be looking at the key situations. Yeah, we have proper orientation and sizing. You must get the orientation of your building right in relation to the direction of sun, direction of wind, and all that. 2. Minimize glazing that is exposed to direct sunlight. Now this is essentially for different climatic conditions. There are areas where you want to maximize, your exposure to solar provision. And there are areas where you want to minimize it. So you must be responsive, like we said, to the environmental prevailing factors. Now, shade exterior glazing. All we are doing here is to say that we want to reduce cost of energy. And how to do that is that we must reduce the solar gains or the heat gains. And the more you do that, the less you have to mechanically respond to the solar gains. And the less you have to mechanically respond to the heat of the building, the less energy cost the owner or the client would bear. So how do you keep heat away? Proper rotation and sizing, minimize glazing exposed to direct sunlight, shade the exterior glazing. Okay, use insulating low heat glass, that's number 4. Minimize the size of all glazing, right? Design an airtight exterior envelope or enclosure. Minimize solar gains in hotter climates and maximize solar gains in colder climates. Like we said before, consider the integration of solar energy. Now there is a program called demand response, and this is another strategy for reducing demand for energy. We'll be looking at that in our next slide. Now, demand response simply means using technologies and programs to utilize energy more efficiently, cut down energy demand, and by so doing, reducing greenhouse gas emissions. Now, this involves things like using less electricity or using it when it's off peak times. And this encourages people in buildings to use less power when it is most needed. That is, when you are really pressed to use power. It's a program to drive people not responding to the pressure of use. Right? The main idea is to help utility providers to distribute energy better. Now, what would we benefit by this approach? It helps the utility providers to avoid building more power facilities and distribution lines. What we are trying to discourage is unnecessary and uncontrolled expansion of power facilities. Okay? It also balances renewable energy with traditional sources. So it has good benefits to the environment and, of course, socially. To join this program, buildings would need to have installed equipment that can reduce or shift energy use. And the project teams are always encouraged by LEED to get involved. Now, in the demand response program, there are two main strategies. One is tiered pricing, as we also have the incentive programs. These reward people who change their energy use when they receive signals over the network during demand response event. Though this event happens rarely, or maybe during when the electric grid is under serious pressure. So it's like a last defense line, and the participants obviously will get rewards and compensation based on the program they're subscribed for. It's all right. So next we're going to be talking on energy efficiency. Energy efficiency, on the other hand, it's about reducing the energy that is needed for product and equipment without necessarily sacrificing the functional requirement. And it has to be a cost-effective approach. Now, this is different from energy conservation, which means you are giving up the service. So the best way to do this is with a team approach from the beginning of a project to its operation, focusing on integrated design. So there are benefits like giving us better mechanical system function by value engineering, more load reduction, and the use of smart operational controls. Using energy modeling simulation now helps the teams to assess their performance. I've integrated all of those strategies. Locate opportunities to improve efficiency, and then decide on the best choices amongst the systems available. To achieve energy efficiency, it is important to include energy demand strategies for peak performance. So we're going to be mentioning the strategies for energy efficiency. Now, the building envelope design. Pay attention to it. Determine mass of the size of your project. Determine mass, the provisions made, the energy modeling simulation, heating and cooling loads, natural ventilation, lighting design and controls, and also appliances. So we'll pick the strategies one after the other and try to. The building envelope design is the outer shell, and it is crucial for saving energy and controlling the temperature within the building. So when you use materials that are energy efficient during construction, you have already reduced the energy that will be required for heating and cooling. There's more information about the building envelope design on this slide. Take your time to study it thoroughly, as it will contribute quite some good knowledge to the attention that needs to be paid building envelope. Now, this is an illustration that demonstrates how that a building can gain or lose thermal heat, through intentional ventilation or unintentional droughts, through the building elements such as walls, floor, windows. You can gain through the sun, as a source of heat gain. There's energy stored in the mass of the building. There are also external temperature, wind, and speed. So this is showing us one illustration of how the building envelope is important to thermal heat gain or loss. So we talk about thermal mass, which talks about how a building's material resists temperature changes. Materials with high thermal absorption contribute to the building's total thermal mass, storing energy absorbed from the sun, and of course releasing it over time. The heating, ventilation, and air conditioning is also another area that is crucial for energy efficient building design, which is aimed at achieving a reduction in energy consumption. This is important. Efficient integration of the HVAC systems with the overall building design, taking into account the envelope system and climatic conditions, can result in significant energy savings. So attention has to be properly paid to the HVAC design. And you see, that's where some professionals get it wrong. All efforts will be made to ensure that strategies are integrated, but because the professionals work in isolation and they lose out on the benefit of synergy. So that's why here it is important for there to be an efficient integration of the HVAC systems in the overall building design, and areas for maximization of efficiency is identified and integrated effectively. Natural ventilation is another approach for improving efficiency by using free resources like wind and outdoor clean air to cool buildings, which create a more productive and healthy working space. And of course, like we said before, the general well-being of all those who interact with the building. Again, we have lighting design and control strategies. Lighting contributes significantly to energy loads. In the design phase, the project teams are encouraged to opt for energy efficient lighting components, controls, and systems. This will help through maximizing daylight, large enough windows. Don't forget what you said about massing, sizing, skylights, which reduce the demand for mechanical or what you call artificial lighting. And in the ventilation, there are options of the placement of the building elements that either will contribute maximally to promoting natural ventilation in the building or otherwise. For the illustration we have here, the lower row shows the different ways and impact of the way building elements are positioned within the green building for you to maximize the benefit of natural ventilation. Next, so we talk about the lighting design and the strategies identified to achieve high energy efficiency from our next slide. Because in lighting design, to achieve high energy efficiency, we talk about the quantity and the quality. This is understanding requirements and the functional needs so that there's no excess provision. Secondly, outdoor artificial lighting. This is about directing the lighting where needed using LED fixtures, also for high quality and performance. Also, we have compact fluorescent lamps, CFLs, for energy savings, for longer lifespan, and for lower heat production. Of course, we have an LED lamps. We have day lighting. We have lighting controls. So these 6 are the high energy efficiency strategies using lighting design. So next we'll be looking at the concept of Energy Star, like we said about water sense level. It's a leveling program that was also initiated by US Department of Energy and EPA in 1992, promoting awareness of energy efficient products. When Energy Star labeled equipment are installed, it's saying to us that the equipment ensures energy efficient practices across various categories. We have the reference standards for buildings, for energy in buildings under this topic, and need you to pay attention. Actually, 90.1 is the energy standard for buildings, apart from low-rise residential buildings. Now, this standard establishes minimum requirements for energy efficiency, with LEED utilizing hash rate 90.1-2013 for awarding energy points. So please take note of the reference standards that we already mentioned for energy in buildings. This is an illustration of the Energy Star label and how you find it on compliant appliances. Now let's look at refrigerant management. Refrigeration and air conditioning contribute to carbon footprint through the emission of greenhouse gases, notable chlorofluorocarbons, CFC, and hydrochlorofluorocarbons, HCFC. Now, these substances adversely affect the stratospheric ozone layer, prompting a heightened focus on sustainable refrigerant alternatives. Organizations are exploring environmentally friendly alternatives to mitigate the environmental impact of these dangerous refrigerants. And we have done this with a mind to balance the initial cost, cooling performance, and leakage rates. Alright, so there are some key areas that you need to take note of. We'll be speaking to under the subject of refrigerant management. We will talk about the refrigerant impact, the chlorofluorocarbons that I mentioned earlier, and the hydrochlorofluorocarbons or hydrofluorocarbons, the Montreal Protocol, the refrigeration design, the properties of the refrigerant or the refrigerants, the ozone depletion potential ODP, and global warming potential GWP of common refrigerants. And then we talk about phase-out plan of old installations using the BAM, CFC, and other strategies and steps, US EPA's GreenScore, and also HANOS. Refrigerants pose a threat to the environment because they have high global warming potential and also ozone depletion potential. Now we said compounds like CFC and HCFC contribute to ozone layer depletion that lead to health issues and ecological disruption. Also, HANOS is found in some fire extinguishers are even more dangerous and also recognized as ozone depleting compounds. Now we've talked about the Montreal Protocol. What's it about? The Montreal Protocol is an international treaty, right, that addresses the issue of ozone depletion and global warming. And this protocol mandated that harmful ozone depleting substances like CFC must be phased out. This protocol came to be in 1987. So you want to pay attention to this, right? And the treaty achieved universal participation and agreed to replace traditional gases with environmentally friendly alternatives like hydrofluorocarbons. Alright, so this what makes the issue of refrigerant selection very important. This is primarily about choosing appropriate refrigerants for improving equipment performance and then reducing operating costs. Synthetic refrigerants, the ones that are not natural, like the CFCs, HCFCs, and HFCs, and natural refrigerants like hydrocarbons carbon dioxide, ammonia, water, and air are two categories of base refrigerant. The first group have their drawbacks because of their ODP and the global warming potential. Whereas natural refrigerants have zero ODP and global warming potential that is negligible and is in alignment with natural biogeochemical cycles. So, what are the best practices in managing refrigerant? Efforts to minimize leakages are essential, considering the environmental hazard they pose and operational losses associated with such leaks. So, recycling ozone depleting compound and safe disposal requirements are some of the ways where the risk that we mentioned can be mitigated. Now, green cooling technology primarily emphasizes environmental friendly air conditioning and refrigeration, combining maximum energy efficiency with natural refrigerants. And we mentioned the phase-out plan and the US EPA's GreenScore. What the phase-out plan is about is to target the production and import of ozone depleting substances with a view to requiring a phase-out for projects that still have CFC, how they can be phased out beyond occupancy, after occupancy. Okay, a project intends to get LEED certification, but it's already having CFC in installation. Okay, there has to be a phase-out plan to get that dangerous substance or dangerous refrigerant out of the game. So this is what phase-out plan is about. For the GreenScore, this is a partnership with food retailers, and it focuses on reducing refrigerant emissions by using more environmentally responsive refrigerants and green refrigeration technologies. Right? We'll be talking about renewable energy in our next slide. Over the last 2 centuries, a significant portion of energy has been derived from non-renewable sources, leading to depletion. And because demand will continue to increase, there is a need to go into renewable sources as sustainable alternatives. Renewable energy is derived from natural sources that are also naturally replenished. Sunlight, for example, wind, geothermal heat, tide water, and various forms of biomass. There are the types of renewable energy that are considered by LEED. I mentioned them about now. Solar power systems are recognized. Photovoltaic cells, wind power, geothermal heating and electric, biomass, biogas, and low impact hydroelectricity. There are about 5 non-eligible types of renewable energy that we also need you to mention. So take advantage of the ones that are considered eligible. And these 5 that cannot sing as eligible renewable energy: architectural features, passive solar, daylighting, geo exchange, and also green power from off your side. So some areas we look at under renewable energy will explain more the passive solar energy, of course also the active solar energy, the solar thermal systems, wind energy, hydro energy, and also biofuel. We also have the wave and tidal power systems. We have geothermal heat pumps, ground source heat pump, green power, carbon offset, common types of offset. So let's talk about passive solar. Passive solar energy design. This is the foundation of renewable energy. It operates without any mechanical devices. Examples include greenhouses, sunrooms, and solar tubes or solariums. Sunlight penetrates glass windows into surfaces, absorb and retain the heat, relying on the building's orientation and the thermal mass of exterior walls. So this is just taking advantage of natural provisions without any mechanical support. That is the passive solar energy. On the other hand, the active solar energy involves mechanical devices to collect, to store, and to distribute solar energy. This is the opposite of the passive system. We also have the solar thermal systems, which harnesses solar energy for thermal or electrical energy, and it actively generates low-cost and environmentally friendly thermal energy, heating water or fluids for various applications. So that's the solar thermal system. This image here shows us an illustrative difference between the active solar system and the passive solar system. Now, wind energy. The wind power converts natural wind into mechanical energy and electricity, giving us clean, renewable source without water consumption or greenhouse gas emissions. The advantages include very fast installation, significant energy contribution. The rural community are able to benefit. Sustainability is an advantage, and also long-term cost effectiveness. We have the hydro energy. You want to study that carefully. We have the biofuel. You want to also take a look carefully at what this means. We have the wave and tidal power systems, which utilizes ocean wave energy to pump turbines, and then the tidal energy captures rising and falling tides behind the dams, which now results into electricity generation. Now we also have the geothermal heat pumps and ground source heat pump, as well as the green power, which is sourced off-site. But I'd like us to look at this image of a geothermal system, how it is harvested, from the subgrade or beneath the earth of the building, and then how it is transmitted to be maximized for use, most of the time for heating the buildings. Okay, now there's what we call renewable energy certificates. The renewable energy certificate represent the environmental attributes of renewable energy projects, which allow projects to support clean energy even without direct access to power. We'll be speaking more to the renewable energy certificate at some point when we are revisiting the keywords of the various parts of this subject. As we begin to run, carbon offsets enable organizations to support projects that reduce, absorb, or prevent emissions, which mitigates their environmental impact. So this is essentially what the carbon offset speaks to. In conclusion, we'll be talking about the ongoing performance. Now, this primarily talks about optimizing building performance through continuous monitoring, through maintenance and adherence to commissioning, measuring and verification, metering, building automation, energy star portfolio management, energy audit, and flush out practices to ensure operational efficiency and savings on energy. LEED standards would guide us on all the ongoing efforts to perpetuate the gains of sustainability. In our next chapter, we'll be looking at the category of materials and resources. I'll see you there.